Hi, in the last video I introduced the Poynting vector. This vector's magnitude is the power density per unit area, and it points in the direction of propagation of the electromagnetic wave. The name Poynting vector with a y is not because it is pointing with an I in any particular direction, but because of the surname of the first person, John Poynting, who derived it. It is the directional flux of energy of the electromagnetic wave. The electric and magnetic fields are perpendicular to the Poynting vector, and they are perpendicular among themselves also. This is a consequence of satisfying Maxwell's equations. We also found that the electric and magnetic fields are proportional, which means that they oscillate in phase. So when the E field is 0, the B field is also 0, and when the E field is maximum, the B field is also maximum. But because these fields are oscillating, the Poynting vector is also oscillating. So in order to calculate the energy flux, we might want to calculate an average value over one oscillation. Because the average value of a sine squared or a cosine squared is 1/2, then we have that the average of the power density of an electromagnetic wave is 1/2 of epsilon naught c squared E naught B naught. To this we shall call the irradiance. Using the relationships we found in the previous video between the magnitudes of the B naught and E naught, we can rewrite this as or now, electromagnetic waves are oscillations of electric and magnetic fields propagating in the direction of the Poynting vector. But because of the constraints between these three vectors, we only need one of them to describe the full wave. For example, just the electric field will suffice. To the direction of the electric field, we call it the direction of polarization of the wave. For example, if the wave is described by the equation E naught sine of kz minus omega t in the x hat direction, the wave is polarized in the x direction. From here, the B field is written as E naught over z sine of kz minus omega t in the y hat direction. And the Poynting vector S is epsilon naught z E squared sine squared of kz minus omega t in the z hat direction. If the electromagnetic wave affects an electric charge, this charge will experience the Lorentz force, F equal to Q times E plus V times B. Polarization of light can be linear, as described with the previous equation, but it can also be circular or elliptical. In that case of linear polarization, the electric field is always oscillating in the same axis, for example the x-axis. It could also be diagonal or in any direction. But the electric field could also be oscillating but changing the direction of this oscillation. This would lead to elliptical or circular polarization. For a diagonal linear polarization, the wave is described as E naught sine of kz minus omega t x hat plus E naught kx minus omega t y hat. For a circular polarization, the wave would be written as E naught sine of kz minus omega t x hat plus E naught sine of kz minus omega t plus pi over 2 I hat. This 90 degrees phase shift is making the polarization move in circles on the plane perpendicular to the direction of propagation of the wave. Polarization is a very interesting phenomenon that you might have already used. For example, the polarized sunglasses filter light polarized in a specific direction and allow the other directions to go through. This is a way of filtering the amount of light going to your eyes. Also, if you have been to watch a 3D movie, you use those 3D glasses, which actually are just polarized filters. Each eye, the right or left, that has a filter in front of it that filters and allows to pass light polarized in a specific direction. The direction of one of them is opposite to the direction of the other one. On the screen you are seeing two movies overimposed, and each one of them has a different polarization of the light going to your eyes. The glasses select the one movie per eye. Each one of the movies has been filmed with two cameras separated just the same distance as that between your eyes, and then the brain does the processing and interprets the two slightly different movies as if you were there watching this scene from inside, which gives you the impression of depth and 3 dimensions. But you can also use polarized filters and polarized light to avoid glare, to study tension on a structure, or to encode information, among many other applications. If you put two lenses polarized in opposite direction, they will not allow any light through. The first one will only allow light from horizontal direction, and the second one will only allow light in the vertical direction. If you put them parallel, then the second one does no extra blocking of light. Funny things happen when you have 3 polarized filters and you play with the relative directions, but I'll let you to discover those interesting results. May science be with you.